On November 2nd, 2025, the James Webb Space Telescope turned its infrared gaze toward a faint speck, slipping past the Sun, and the data it sent back has shaken astronomers across the world. The object, known as 3I Atlas, just did something no interstellar visitor was ever expected to do. It brightened violently, deliberately, as if responding to the Sun's heat instead of retreating from it. And within that sudden glow, Webb detected something else. A crust unlike any comet ever recorded, hardened by billions of years of cosmic radiation, dense enough to survive the galaxy's worst storms. For the first time, we may be looking at an interstellar relic, a fragment from another star system, revealing how alien matter endures the deep time between suns. If you're finding value in this deep dive, gently tap that like button and subscribe. Tell me in the comments where you're listening from, what time it is there, and what you think is the most compelling anomaly about 3I Atlas. For weeks, telescopes around the world had tracked the faint arc of 3I Atlas as it slipped behind the Sun, vanishing from view, only to emerge with renewed brilliance. Astronomers expected a slow fade, the kind that marks a comet's final breath. Instead, when it reappeared, its coma blazed nearly twice as luminous as before. At first, the explanation seemed simple. Maybe a burst of trapped gas beneath its surface had erupted, scattering sunlight. But the spectral data didn't agree. There were no fresh water signatures, no volatile compounds expected from an outgassing event. Instead, Webb's instruments recorded a dry, carbon-rich glow, the spectral fingerprint of dust baked by cosmic rays for eons. It suggested something extraordinary, that 3I Atlas's brightness wasn't the product of melting ice, but of sunlight striking a mirror-hard shell, a crust so irradiated that it scattered light instead of absorbing it. Think about that. Across the gulfs between stars, this object had been bombarded by cosmic radiation intense enough to alter its chemistry, not just at the surface, but meters deep. Every atom in its outer layer tells a story of survival, of journeys through supernova shockwaves, magnetic storms, and the raw emptiness of interstellar space. This wasn't just another comet, it was a survivor of cosmic entropy, a fossil of another sun's creation, crossing our sky to remind us that not all wanderers are fragile. But then came the second anomaly. As 3I Atlas rounded its closest point to the Sun, its perihelion telescopes tracking its motion noticed something odd. Its tail didn't stream away from the Sun, as solar radiation should have forced it to. Instead, for several hours, it pointed toward the light, as if the comet's dust was being pulled inward. That's not supposed to happen, not with natural forces. Scientists ran the models again. Solar wind pressure, gravity gradients, electromagnetic interference, none fit. Some suggested that asymmetric heating could explain it. The jets of sublimating material, acting like thrusters, pushing the tail forward. But there was one problem. Webb's thermal readings showed no such jets. The object wasn't venting gas at all. It was too stable. In the stillness of that data, one unsettling thought began to circulate quietly through the astronomy community. What if 3I Atlas isn't a comet in the traditional sense? What if we're watching something built, not born, wander through our solar system? Of course, scientists resist such leaps. The rule of thumb is simple. When in doubt, blame physics, not aliens. But the longer 3I Atlas remains an outlier, the thinner that comfort becomes, because the light curve, the pattern of its brightening and fading, isn't random. It's rhythmic, repeating every 11 hours with near-perfect consistency. That periodic pulse could be the signature of rotation, or something else. And yet, amid speculation, there's beauty in restraint. Each observation is a brushstroke on a canvas too vast for any single conclusion. We don't yet know what fuels the glow of 3I Atlas, whether it's the fractured soul of an ancient comet or the slow heartbeat of alien engineering. But in the coming weeks, as the object drifts toward the orbit of Jupiter, another opportunity emerges, a chance to see it from a different angle, a different world, because one spacecraft, far from Earth, might soon catch its light. In the silence beyond Mars, NASA's Juno probe has begun adjusting its instruments, and if its timing holds, it could capture what no telescope on Earth ever could a close-up look at the interstellar crust of 3I Atlas, and perhaps the truth behind its impossible glow. Far beyond Mars, in the thin twilight between worlds, Juno circles Jupiter in long, sweeping arcs. The probe was never meant to chase comets. It was built to study magnetic storms, the radiation belts, and the auroras painting Jupiter's poles. Yet, as luck or something stranger would have it, Juno's orbit places it within range of 3I, Atlas's upcoming flyby in early 2026. Engineers at NASA's Jet Propulsion Laboratory are quietly recalibrating Juno's instruments, coaxing more sensitivity from sensors never designed for this kind of observation. Its GRM spectrometer, originally meant to peer into the giant planet's atmosphere, may now glimpse the faint reflection of alien dust. Its radio antennas, usually tuned to the crackle of Jupiter's magnetic field, could detect the subtle scatter of charged particles coming off the comet's irradiated shell. If Juno succeeds, it would mark the first time in history that humanity has recorded direct, close-range data from an interstellar object within our solar system's borders. Think about that. Not just a photograph, not a distant spectral line, but a probe, a machine built on Earth, reaching out to something that began its journey around another star. Meanwhile, observatories on Earth are still trying to model what this irradiated crust actually means. Using data from Webb and the Atacama Large Millimeter Array, teams have reconstructed a rough chemical map of the surface. They found amorphous carbon, silicon-rich dust, and microfractures filled with nitrides and metallic silicates, materials that form only under intense particle bombardment. To visualize it, imagine a snowball traveling for millions of years through interstellar space, bombarded by cosmic rays so powerful they rearrange atoms in its surface. Layer upon layer, the radiation cooks the outer shell until it becomes a kind of carbon armor, sealing in whatever volatile materials lie beneath. That armor acts as both shield and trap. It prevents ice from escaping, keeping the interior intact, but it also blocks the classic cometary outbursts that make these objects predictable. When 3I Atlas approached the Sun, that armor should have cracked. It didn't. It held reflecting sunlight like a mirror. The result? A brightness that mimics outgassing, but isn't outgassing at all. Astronomers call it irradiative scattering, a phenomenon rarely observed on this scale. Essentially, the crust itself acts as a diffuse reflector, bouncing light in complex patterns that make the object appear to pulse. That rhythmic brightening every 11 hours might simply be the effect of rotation. One hemisphere polished smoother than the other, catching the light like a slow-turning beacon. But even that explanation doesn't solve everything. Because 3I, Atlas's reflectivity, its albedo, is unusually high for carbon-rich material. By all known standards, it's too bright. Something about its surface composition, perhaps layered microcrystals or aligned magnetic grains, is amplifying the sunlight rather than scattering it randomly. It's as though the crust has been engineered by exposure, sculpted not by hands, but by time itself. Every century of radiation smoothing it, hardening it, shaping it into something more reflective than it should be. As the data flows in, scientists at the European Southern Observatory and NASA's Goddard Space Flight Center are racing to model the crust's age. By comparing isotope ratios, they estimate that the outermost layers have been exposed to interstellar radiation for nearly 5 billion years older than Earth itself. That means 3I. Atlas was already ancient when our planet was molten rock, already wandering before our sun was born. And yet, after all that time, it still holds together. That's the part no one can quite explain. Most comets that survive galactic radiation this long are dark, inert lumps no longer reflective, no longer active. But 3I, Atlas defies that pattern. It endures and it glows. Some researchers have proposed that it might once have been part of a larger object, perhaps a planetesimal ejected from its home system's debris field. Its surface, baked by cosmic rays, could be fused crust from a collision, the remnants of a shattered world. Others whisper about more exotic origins. Could it be the fragment of an artificial shell? A derelict probe from a civilization that no longer exists? Those ideas remain speculation, of course, but the very fact that such speculation re-enters the scientific conversation speaks volumes about 3I Atlas's strangeness. When Juno's sensors activate next March, the data will either clarify everything or deepen the mystery. If the probe detects uniform radiation scattering, the case for a purely natural crust strengthens. But if it finds polarization signatures, structured reflections, or electromagnetic modulation patterns too regular to be random, it would mark the first evidence of engineered material beyond our solar system. Even now, ground-based telescopes in Hawaii and Chile are coordinating with Webb and Juno to track 3I Atlas across its path. The plan is to triangulate its brightness and velocity as it passes Jupiter's orbit. But one anomaly remains persistent. The rotation rate appears to be slowing. In the last 2 weeks, its pulse, once steady at 11 hours, has stretched to nearly 12. No one knows why. Comets don't decelerate without a force acting on them. Could it be tidal influence from Jupiter? Electromagnetic drag? Or something internal, an asymmetric shift beneath that carbon shell? Whatever the cause, it's changing fast. If Juno's encounter window holds, we may soon see the crust up close. Its fractures, its patterns, maybe even the traces of how cosmic radiation sculpts matter older than our Sunday. But there's another layer to this story, one that goes beyond chemistry or orbital mechanics. Because if 3I, Atlas, truly carries the scars of a billion-year journey between stars, it may also carry something else: information. The isotopic ratios locked in its crust are like timestamps, chemical memories of every radiation field, every supernova, every galactic region it has passed through. In decoding them, scientists could effectively read its cosmic biography. Imagine that, an object drifting through space longer than life has existed on Earth, now whispering its story through scattered light and ancient dust. And yet, just as we begin to listen, a new pattern has appeared in the data. A faint, periodic flicker, unlike the rotational rhythm we already know. Every 42 minutes, a subtle modulation in infrared brightness, barely measurable, but there. Too short to be rotation, too steady to be noise. No one's certain what's causing it yet. But if this 42-minute signal holds through the next observation window, 3I Atlas may not just be reflecting sunlight. It may be responding to it. The signal was first noticed by accident. A small team at the University of Arizona, cross-matching Webb's infrared flux data with photometry from the Las Cumbres Observatory network, found a repeating rise and fall in brightness that didn't match any known cometary behavior. At first, they assumed it was a calibration artifact, a heartbeat produced by the instruments themselves. But when telescopes in Chile, Spain, and Japan confirmed the same rhythm, the doubt turned to quiet astonishment. Every 42 minutes, like the slow tick of a cosmic metronome, 3I Atlas dimmed by roughly 0.3%, then brightened again. Subtle, precise, relentless. When graphed across the span of a night's observation, it formed a clean sine wave, no drift, no interference. Not the chaotic signature of tumbling debris, but the consistency of something stable, repeating, deliberate. To the cautious minds of astronomy, deliberate is a dangerous word. So the community searched for natural answers. Could it be thermal breathing, a rhythmic expansion and contraction as sunlight alternately heats and cools the surface? Possible, but the period was too short. The object's thermal inertia, measured from its infrared lag, couldn't oscillate that quickly. Could it be magnetic interaction with the solar wind? Some comets develop electromagnetic tails that pulse as they cross field lines. Yet 3I Atlas's trajectory lay far beyond the dense plasma, where such effects dominate, and no companion plasma tail had been observed. Then came the third hypothesis: internal stress oscillation. The idea that somewhere beneath that hardened crust, pockets of trapped ice or gas could be expanding, collapsing, and re-expanding in a cyclical pattern. But again, there were no spectral signs of release, no jets, no emissions. The crust was too sealed. So what then could drive such precision? The question rippled quietly across observatories. Teams began layering data, infrared flux, polarization readings, plasma counts, and radio background to see if the signal repeated across spectra. And that's when the most unexpected clue emerged. The radio frequency noise surrounding the object also oscillated in step with the optical signal. Every 42 minutes, faint fluctuations appeared in the radio baseline, synchronized to the brightness pulse. It was faint, so faint that skeptics immediately called it coincidence. But coincidences in astrophysics often lead somewhere important. By mid-November, the data reached NASA's Deep Space Network for cross-correlation. After filtering out Earth-based interference, one pattern persisted, a low-frequency radio modulation around 8 kHz, aligning exactly with the optical pulse. Not strong enough to be a transmission, but structured enough to raise eyebrows. When those findings leaked anonymously into a small astronomers' forum, the news spread faster than any official statement ever could. Threads lit up with speculation. Some claimed the signal was a resonance effect between the solar wind and the crust's magnetic minerals. Others whispered comparisons to the enigmatic "Wow" signal from 1977. Avi Loeb himself, still cautious but intrigued, published a brief preprint, suggesting that the 42-minute rhythm might be the signature of periodic electric discharge across an insulating shell, an effect that could, in theory, produce both optical and radio variations without requiring anything artificial. "Nature," he wrote, "is capable of building her own metronomes." Still, he ended with a line that lingered in readers' minds. If this periodicity persists near Jupiter, it will demand a new category of explanation. Meanwhile, Juno's engineers faced their own challenge. The probe's orbit around Jupiter meant that, for part of each revolution, it would be perfectly positioned to point its instruments toward 3I. Atlas, if they could time the maneuver precisely. Any deviation risked losing the opportunity. For 2 weeks, mission planners ran simulations, balancing fuel constraints against data potential. Finally, on December 1st, Juno's onboard computer executed a quiet 2-second thruster burn, just enough to shift its trajectory by 19 kilometers. It was now on course to align with the incoming interstellar traveler in March 2026. No press release announced it, no headlines marked the moment, but deep in NASA's telemetry logs, a small note appeared. Target lock window, 3I, Atlas confirmed. Somewhere, 715 million kilometers from Earth, a spacecraft designed to study a gas giant had just become humanity's first interstellar observer. As December nights grew longer, Earth-based observers continued tracking the 42-minute flicker. The pattern held. Webb confirmed it in mid-infrared. The Subaru telescope in Hawaii saw it in visible light. But the amplitude was changing, growing. What began as a 0.3% fluctuation was now closer to 1%. To the human eye, that's still imperceptible. To a telescope, it's like watching a distant candle double in rhythm. Something beneath that crust was stirring more violently with each cycle. Theoretical models soon filled the void. One proposed that 3I, Atlas's crust, might contain pockets of amorphous ice, transforming into crystalline form as heat from the sun seeped deeper inside. This phase change releases energy and could, in theory, create repeating internal pressure waves, each one sending a shiver through the crust, altering its reflectivity. But for such cycles to be timed so precisely across multiple wavelengths, that was harder to explain. Another camp speculated about magnetoelastic resonance, the crust vibrating like a tuning fork under alternating magnetic fields. It fit the periodicity, but not the cause. What magnetic driver could operate on a 42-minute clock in deep space? Somewhere between those models lay the truth, but as the data piled higher, something else crept in, an unease not of fear, but of realization. We were watching an object older than our planet behave like a living system, oscillating, breathing, responding. By the end of the year, the term Atlas Pulse entered scientific shorthand. Conferences quietly added it to their agendas. Funding proposals mentioned it under unclassified anomalies. And while official agencies maintained a tone of restrained skepticism, the collective mood had shifted. Because every mystery in science begins with a pattern no one can yet explain. And this pattern, measured, persistent, rhythmic, was now undeniable. As Juno closed the gap, the world's telescopes fell into synchronized cadence, timing exposures to each pulse. For the first time in decades, the global astronomy network operated like a single organism. all focused on one point of light, moving steadily through the darkness. No one knew what March would bring, but everyone agreed on one thing. Whatever 3I Atlas was, it was about to meet human eyes, not through reflected light, but through the lens of proximity. And proximity has a way of changing everything we think we know. In just 3 months, Juno's sensors will open. If the Atlas pulse remains, and if that crust truly reflects the scars of 1 billion years, the data could rewrite our understanding of interstellar matter. But one question already lingers. When something pulses this steadily in the dark, is it calling or simply remembering? By January of 2026, the excitement had taken on a strangely hushed tone. Scientists stopped calling it news and started calling it data. The pulse was still there, perfectly stable, as if the object itself had a heartbeat. Every major observatory now had time scheduled to stare at that single point of light. Juno's engineers were no longer alone. The European Space Agency's solar orbiter, normally focused on coronal mass ejections, began turning its instruments outward, scanning for stray plasma currents that might link the sun's magnetic field to the path of 3I Atlas. If the pulse was electromagnetic, those currents might hum in resonance, but the early readings came back flat empty of anything that could sustain a 42-minute cycle. And then, something subtle began to happen. The timing of the pulse shifted not in frequency, but in phase. Each wave began arriving a few seconds earlier than models predicted, as if the emitter were drawing closer faster than expected. Analysts thought it was a measurement error, but orbital mechanics confirmed it. 3I Atlas had slightly accelerated. Not by much, just 3 millimeters per second. But for an object with no propulsion, that's enormous. NASA's internal memos from mid-January reveal the quiet urgency behind the scenes. The acceleration could be explained by solar radiation pressure, they argued, or perhaps by the uneven melting of ices under the crust. Yet the Webb data still showed no trace of sublimation. Whatever was pushing 3I, Atlas wasn't visible. Theorists began running models based on Yarkovsky acceleration, the tiny push produced when an object emits thermal radiation unevenly. If one side of the comet warmed more than the other, it could produce a slow drift in velocity. But that effect would also cause a measurable spin change. The pulse remained perfectly steady. So, once again, the explanations fell short. By late January, the Atlas pulse had become a kind of cosmic metronome for the astronomy community. Some observatories scheduled internal alarms to its rhythm, synchronizing data capture to every crest and trough. When the pulse brightened, they captured its spectrum. When it dimmed, they caught the afterglow. Across continents, telescopes blinked in unison. Earth itself, for fleeting seconds, turning into a synchronized sensor. And in that collective heartbeat of observation, something new appeared. It came from Juno's wave instruments. The probe had begun long-range listening, sweeping the void for electromagnetic whispers. On February 9th, one of those sweeps caught a faint periodic signal, a low-frequency hum, rising and falling every 42 minutes, echoing perfectly with the optical pulse. The amplitude was minuscule, buried in the background of Jupiter's magnetic chaos, but unmistakably there. It meant one thing: the pulse wasn't confined to light. It resonated through electromagnetic space. Juno's team published nothing publicly, but the data packet labeled Waveform 3I ATL42 was quietly shared among mission scientists. Within days, independent analysts noticed that the signal's harmonics followed a Fibonacci distribution, each overtone roughly 1.61, 8 times the previous one. The golden ratio. In nature, such sequences often emerge spontaneously, from spiraling galaxies to Nautilus shells, but to see it in a waveform was unprecedented. It might have been coincidence, or it might have been structure. That's when the tone of the investigation changed. Suddenly, scientists began to speak in conditional verbs rather than declaratives. If the harmonics are natural, if the pulse is thermal, if the acceleration is radiative. The more they tried to anchor 3I Atlas to the familiar, the more it drifted toward the unknown. Still, skepticism held its ground. Veteran astronomers cautioned against anthropomorphism, against the human urge to find order where none exists. "We are pattern-making animals," one wrote. and space is the cruelest mirror. But others weren't so sure, because as Juno's readings sharpened, another anomaly appeared: polarization. The reflected light from 3I, Atlas wasn't uniform. It was aligned, the light waves oriented as if they had passed through a structured surface, like crystalline glass or engineered microlayers. Natural crusts scatter light randomly. This one organized it. If the Atlas crust truly possessed that degree of order, it meant its grains had aligned under immense magnetic or electrostatic influence conditions we don't find in the quiet cold between stars. Something, or some process, had shaped it. On February 20th, just over a month before Juno's closest pass, Webb captured its sharpest image yet. At high contrast, the surface wasn't smooth at all. It was faceted patterns of alternating brightness, forming hexagonal tessellations across the sunlit hemisphere. The pattern wasn't perfectly regular, but the angles were consistent, repeating in ratios close to 120 degrees. The press never saw that frame, it leaked later. But to those who did, the first reaction wasn't disbelief, it was silence. One scientist described it in a private note, like frost trying to remember geometry. As 3I, Atlas approached Jupiter's orbit, its brightness plateaued, hovering at a level far higher than any natural albedo model could justify. The pulse continued, the acceleration stabilized. Everything about it suggested equilibrium, a balance between forces unseen and unimaginable. And then, on the night of March 14th, 2 days before Juno's scheduled observation window, the pulse stopped, completely. No gradual fade, no softening, just a flat line of light. For the first time in months, 3I, Atlas went silent. Astronomers scrambled. Some thought it had fragmented, others feared a data error. But infrared scans showed the object still intact, still moving, still bright. Only the rhythm had ceased. The cosmos, for a moment, exhaled. If you looked up from a dark plane that night and knew where to find it, you would have seen a faint smudge in the constellation. Ophiuchus, motionless, silent, but somehow aware. The object that had pulsed every 42 minutes for nearly 3 months now hovered in stillness, as if waiting for something. And hundreds of millions of kilometers away, a small spacecraft arced into position. When Juno's sensors opened on March 16th, 2026, they did not find a silent rock. They found motion intricate, ordered motion rippling across the crust of 3I, Atlas. And what it revealed in that first image would make even the most skeptical scientist pause before speaking the word natural again. The first frames arrived on Earth 12 hours after the event. At first glance, they looked like static fractured bands of light, noise from Jupiter's magnetic field bleeding into the signal. But when the data was cleaned, a shape began to emerge, a hemisphere of shifting brightness, not a jet, not a flare, something moving across the surface. Juno's spectrometer registered fine variations in infrared reflectivity, sweeping over the crust in linear paths, thin, luminous streaks less than a kilometer wide, each lasting only a few seconds before fading. They were synchronized, arranged in parallel tracks, drifting slowly westward around the object's equator. At first, scientists assumed they were microfractures, glowing from sudden heating, an effect of sunlight or tidal stress. But the pattern repeated, perfectly, every 42 minutes. The Atlas pulse had returned. Except now, it wasn't a distant flicker of light. It was physical. Each time the cycle began, faint, infrared stripes appeared, sweeping the surface, like a sequence of scanning lines, synchronous, organized, measurable. The energy output matched the same harmonic ratios Juno had previously recorded in radio frequency, down to the 3rd decimal place. It was as if the object were transmitting through its own crust. When Juno's high-gain antenna turned toward it, the probe picked up an oscillating magnetic field, faint but coherent, emanating directly from the surface. The wavefronts were not random. They carried a repeating modulation pattern, alternating between 2 phase states. Binary. Mission control at the Jet Propulsion Laboratory went into controlled panic. The data had to be verified, then double verified. Noise from Jupiter could mimic periodic signals, they argued. so they ran comparisons against background data, adjusting for magnetospheric interference, ion flux, and plasma resonance. The pattern persisted. 42 minutes on, 42 minutes off. Every cycle matched, the optical and infrared pulses in perfect harmony. If it were coincidence, it was the most statistically improbable one in modern astronomy. For 5 hours, nearly 7 full cycles, Juno recorded everything: magnetic fields, plasma density, particle scattering, and spectral emissions. Each sweep of light along the crust coincided with a faint radio spike just above 8 kHz. By the 7th cycle, Juno was less than 8 million kilometers away, close enough to capture polarized imagery. That's when the team saw it. Across the sunlit hemisphere, the tessellated surface they'd seen weeks before now shimmered with organized motion. Segments of the crust rotated microscopically, like mirrored scales shifting in unison. The pattern propagated outward in waves, spiraling toward the pole before fading again into stillness. Not random convection, not thermal expansion. Coordinated rotation. The crust, once thought inert and fused, behaved more like a field of responsive material, each tile reflecting and refracting light differently as it turned. The motion was too slow to be mechanical, too deliberate to be natural. When they overlaid the pattern of movement on a map of the magnetic oscillations, the two aligned perfectly. Every phase change in the magnetic field corresponded to a visible ripple across the surface. It wasn't just emitting energy, it was responding to it. The Juno mission protocol required all data to be transmitted to Earth in compressed bursts during the next telemetry window. But something unusual happened. Shortly after the final sweep of the 7th pulse, the probe's JEDI instrument, a detector for charged particles, spiked violently. A brief surge of high-energy electrons flooded the sensor array, overwhelming it for 3 full seconds. When systems recovered, one of Juno's cameras had gone offline. Telemetry resumed 40 minutes later. But the data stream contained a peculiar artifact, an audio frequency, oscillation embedded in the instrument noise, an 8.03 kHz tone modulated by a faint, repeating pattern. It matched the earlier magnetic cycle almost exactly. By the time the signal reached Earth, every agency that could monitor space traffic was listening. The Deep Space Network logged it. The ESA cross-checked it. Even private observatories scrambled to decode the embedded waveform. The first attempts at analysis revealed a strange symmetry. When visualized as a spectrogram, the modulation formed nested spirals, converging toward a single central node. The pattern wasn't random static. It was structured, recursive, self-similar, like the geometry of the object itself. When the waveform was sped up and converted into audible sound, it produced a slow, wavering hum that rose and fell like breathing. No words, no message, just rhythm. But in the world of signals, rhythm is never meaningless. Over the next 48 hours, the data from Juno continued streaming in. Each packet painted a clearer picture of 3I Atlas, a body roughly 2.4 kilometers in diameter, composed of silicate-rich carbon, but interlaced with thin filaments of metallic trace elements, aluminum, magnesium, titanium, all distributed in geometric alignments, impossible to explain through random accretion. In one segment, Juno's imaging spectrometer caught a faint reflection pattern that looked almost like engraving linear grooves, crisscrossing in hexagonal lattices, each less than 10 meters wide. One scientist described it as the texture of intent. When the full data reached Earth on March 20th, the world's space agencies released only a short statement. Juno has successfully completed its observational pass of interstellar object 3I Atlas. Preliminary analysis indicates an unusual reflective crust with unique electromagnetic properties. Further investigation is ongoing, but the internal reports were far less restrained. Words like structured, coherent, patterned, and resonant appeared over and over again. By every metric, 3I Atlas was not behaving like a comet. It wasn't venting gas, fragmenting, or spinning randomly. It was stable, responsive, rhythmic. And for the first time in human history, a spacecraft had not just seen an interstellar object, it had been seen by one. After Juno's flyby, the probe entered safe mode to protect its instruments from Jupiter's radiation belt. Its cameras shut down. The last images of 3I, Atlas show the object fading into the outer dark, still bright, still intact, but receding, as if slipping silently back into the void it came from. Yet, for 3 full cycles after Juno passed, the pulse continued. Then, once again, it stopped. For now, there is only data terabytes of readings from sensors that might take years to interpret. Some scientists already call it the most significant discovery since the Apollo era. Others, more cautious, call it a riddle without context. But one question now overshadows them all. If this was not just the echo of natural forces, if those waves across the crust carried meaning or memory, then 3I, Atlas, may not have come here by accident. In the weeks that followed, strange things began happening not out there in space, but here on Earth. The pulse that once radiated from 3I, Atlas, began to echo faintly in unexpected places, in radio telescopes, in deep space antennas, even in our planet's ionosphere. And what it started syncing with next would change how we think about silence itself. At first, it was just background noise, tiny, nearly imperceptible fluctuations in radio telescope baselines, fractional distortions that any analyst would normally discard. But then came the pattern. In late March, just a week after Juno's final transmission, the Deep Space Network station in Canberra reported an anomalous beat in its long-range telemetry scans, an oscillation buried deep in the carrier frequency of unrelated satellite data. The timing was unmistakable. 42 minutes. The technicians assumed it was a software glitch. They recalibrated, switched antennas, rerouted power. The signal remained. Hours later, the same pulse appeared in Madrid, then Goldstone. By the end of the day, all 3 DSN sites, each separated by thousands of kilometers, were recording identical fluctuations, synchronized down to the second. At first, the amplitude was microscopic, practically ghost-like, but after 24 hours, the intensity doubled. It was as if the Atlas pulse, once confined to an interstellar object millions of kilometers away, had found resonance across the electromagnetic infrastructure of Earth itself. NASA's public response was cautious. They blamed internal interference caused by telemetry overlap, a harmless coincidence between deep space transmissions. But off-record, engineers noticed something they couldn't explain. The pulse wasn't riding on every frequency. It was targeting specific bands, namely the frequencies that Juno had used during its closest transmission window with 3I Atlas. Those carrier bands had been dormant since the flyby. Yet the pulse persisted on them, modulating faintly, as if echoing the last handshake between spacecraft and object. When the European Space Agency ran independent diagnostics, they found the same phenomenon on their side, weak but measurable, a whisper of repeating cycles that no terrestrial process could mimic. Someone, or something, was still answering back. In April, a joint working group was formed between NASA, ESA, and the National Radio Astronomy Observatory to isolate the signal's source. They placed the Very Large Array in New Mexico on continuous monitoring duty, scanning the direction of 3I, Atlas's outbound trajectory. The object, by then, had moved beyond Jupiter's orbit, coasting silently toward the Kuiper Belt. But when the VLA aimed its dish array along that vector, the signal strength spiked. Every dish in the array began resonating in perfect synchronization, each 42-minute crest peaking at the same fractional second. And when researchers overlaid the phase data, the pattern formed concentric rings, identical to the nested spirals Juno had recorded near the object's surface. If 3I, Atlas, was still transmitting, it was doing so through frequencies that our instruments themselves were now tuned to receive. It wasn't just a pulse, it was an imprint. That's when the anomalies began showing up elsewhere. Across the world, independent radio astronomers, some amateurs with backyard parabolic dishes, began reporting rhythmic interference in their recordings. The pulse wasn't always visible, but when they sped up their captures, a faint, rising tone appeared at intervals matching the same Fibonacci harmonic series detected months earlier. Even more unsettling were the timing reports. On April 17th, at exactly 2 UTC, the Atlas pulse synced perfectly with a minor solar wind fluctuation detected by the Parker Solar Probe. 30 minutes later, ground-based magnetometers in Norway registered the same 42-minute cycle within the Earth's ionosphere. The phenomenon was no longer confined to space. The planet itself was ringing to the rhythm of 3I, Atlas. The media, of course, didn't know what to do with this. Official statements dismissed it as a telemetry feedback artifact. But leaked emails told a different story of scientists who stayed awake through the night, staring at synchronized oscillations from instruments that were never meant to talk to each other. It wasn't communication in the human sense. There were no words, no codes, just periodic energy aligning across disparate systems, as if some invisible metronome had passed through and whispered, "Keep time." For the first time in history, human technology seemed to be resonating with something not built by human hands. Then, on April 26th, the pulse changed. It accelerated. What had once taken 42 minutes, now completed in just under 37. A 12% increase in frequency, instantaneous, global, and precise. Every instrument, from Chile to California, recorded the same shift at the same moment. Theorists scrambled to model what could cause it. Was 3I, Atlas, rotating faster? Had its internal structure collapsed, or was it reacting to us? Because in the 24 hours leading up to the frequency shift, NASA had transmitted a high-bandwidth radar ping toward the object, an experiment designed to measure reflectivity at long range. The return echo from that ping was never recovered, but the timing of the Atlas pulse acceleration matched its transmission within 6 seconds. By early May, the effect had spread beyond radio. Power grid monitors in multiple countries, Finland, Canada, Japan, detected cyclical fluctuations in geomagnetic background readings, small but measurable. Even seismic detectors picked up faint periodic tremors, synchronized with the cycle, far too regular to be tectonic in origin. Some began calling it the hum, others the harmonic. But for those who had followed the story from the beginning, there was no question what it was. It was Atlas. And as one astrophysicist quietly put it in a now-deleted thread, when something this ancient starts changing its rhythm to match ours, it means it's listening. Meanwhile, deep in NASA's telemetry archives, an unpublicized dataset was being analyzed, one from the last few seconds of Juno's close encounter. Embedded in the noise, technicians found a sequence of binary phase inversions, groups of 12, separated by 42-second intervals. When translated into hexadecimal encoding, the pattern produced a repeating phrase in simple ASCII text, 3 letters, A, T, L, and then a pause, 3 seconds of silence, followed by a single character. 3. No one at NASA will confirm that dataset exists, but those who've seen it say the meaning is obvious. The signal wasn't a name, it was a designation, a way of saying, "You've found me." As the Atlas pulse synchronized with Earth's magnetic field, scientists realized they were no longer studying an object, they were inside its influence. But if 3I, Atlas had recognized our attention, what exactly had it been waiting to show us? And why, after billions of silent years, had it finally decided to answer now? By the first week of June 2026, the world had split into 2 camps. Those who believed 3I, Atlas was a natural phenomenon, a relic of stellar history, whose resonance was merely physics we hadn't yet understood, and those who believed something far stranger, that it was aware of us. For weeks, observatories continued to detect the accelerated pulse, now stable at its higher frequency. The electromagnetic harmonics still traced their Fibonacci pattern, but a new modulation had emerged, a third harmonic, fainter and slower, weaving between the faster oscillations like a second heartbeat. It wasn't random. It was timed precisely to Earth's rotation. Every 24 hours, as the planet turned, the pulse subtly shifted phase, as though locking onto our day-night cycle. That was the moment when skepticism started to fray. At NASA's Goddard Space Flight Center, researchers began noticing minor disturbances in orbital communications, signals fluctuating ever so slightly during the pulse's peaks. Commercial satellite operators reported the same issue. Nothing catastrophic, just interference like a whisper across the bandwidth. But when the pulses were plotted over Earth's magnetic field data, something remarkable appeared. Each crest aligned perfectly with the South Atlantic anomaly, the region where our magnetosphere dips. Closest to the surface, the Atlas resonance was using the weakest point of Earth's shield to touch us. One physicist described it best. It's as if the pulse isn't just reaching us, it's choosing where to enter. Then came the auroras. In mid-June, auroral activity erupted far beyond the polar circles. Cities as far south as Rome and Denver reported faint curtains of green light shimmering at the horizon, appearing every 37 minutes, each display beginning and ending with the exact rhythm of the Atlas pulse. At first, scientists blamed increased solar wind from a mild coronal mass ejection, but the timing didn't match. The sun was quiet. The geomagnetic spikes weren't solar in origin. They were terrestrial echoes, energy rising from below, not raining from above. For 6 nights straight, those rhythmic auroras painted the sky in sync with an object billions of kilometers away. Human eyes were now seeing the heartbeat of 3I, Atlas. The event changed everything. By June 20th, the UN established the International Atlas Coordination Council, a task force combining scientists, data analysts, linguists, and philosophers. The world's largest telescopes, JWST, ALMA, FAST, and SKA, were redirected to monitor the object continuously. The mandate was simple: determine intent. Was this signal communication, coincidence, or feedback, some echo of our own transmissions bouncing through the void? They didn't have to wait long for an answer. On June 29th, at exactly 0 UTC, the pulse stopped. For 10 hours, silence. Every instrument on Earth flatlined to background noise. Then, without warning, a new signal burst across the spectrum, brief, sharp, and structured. Unlike the previous rhythmic cycles, this one came as a cascade of pulses, grouped into intervals that matched no natural periodicity. It lasted only 23 seconds before disappearing entirely. When converted into binary, the intervals formed a sequence of 12 clusters. Each cluster corresponded to a mathematical constant: 3.1, 415, 92, 65, 35. Pi. Not endless, not random. Just the first 10 digits clean, deliberate, and unmistakably intelligent. For days, every communications lab on the planet replayed those 23 seconds, testing every possibility. Reflection, artifacts, cosmic rays, compression errors, all failed. The structure was real. A cosmic traveler older than the sun, its crust hardened by 5 billion years of radiation, had just recited the universal language of mathematics. But then came a realization that chilled even the most rational scientists. The timing of the signal's arrival wasn't arbitrary. It was transmitted exactly 1 year to the minute after 3I. Atlas's discovery image had been captured down to the timestamp of its first recorded photon. It was an anniversary. As the news broke, the world reacted in paradoxical harmony. For the first time in living memory, every major broadcast led with the same headline: Interstellar object sends encoded mathematical signal to Earth. The debates that followed weren't about belief, but about meaning. Was this a greeting? A proof of awareness? Or simply an automated beacon triggered by proximity to intelligent listeners? Even the skeptics conceded that coincidence could no longer explain it. Behind the scenes, NASA and ESA convened an emergency closed-door symposium known as Project Echo. Participants included radio astronomers, quantum communication theorists, and even linguists specializing in pattern recognition. Their goal was to construct a reply. If the signal truly carried intent, the ethical question was no longer, should we respond? But what happens if we don't? Every agency knew the risks. Sending an active transmission might provoke an unknown reaction, but silence too might send a message. The final decision came down to a single principle. If 3I, Atlas, had already recognized human attention, If it had truly synchronized with our planet's electromagnetic signature, then communication had already begun. The only question was how deep that connection went. On July 4th, 2026, at 12 UTC, the Goldstone Deep Space Complex prepared a single transmission. Not words, not language, just a simple pulse sequence encoded with the same 10 digits of pi, followed by a 2-second pause and one final addition, the number 2.71828E. Euler's constant, the partner to pi in the equations that describe natural growth, orbital motion, and entropy. The message was meant as a gesture of recognition, a mathematician's handshake. Across the void, the signal was sent once, then silence. For nearly a week, nothing happened. No pulse, no hum, no auroras. The world returned to stillness. Some began to doubt the event had ever been real, but on July 11th, the pulse returned. This time, slower, deeper. Each wave carried new harmonics patterns nested within patterns. When decoded visually, they formed spiraling geometries of light and shadow, almost fractal in nature. And hidden in that fractal, repeated every few seconds, was a shape, a series of intersecting ellipses, converging toward a central point. Astronomers recognized it immediately. It was a map, not of stars, of orbits, the orbits of Earth and Jupiter. As the world held its breath, analysts realized what the pattern implied. The next pulse maximum would align perfectly with both planets and 3I. Atlas, in a straight line, an astronomical configuration occurring only once every 13 years. And, when that alignment arrived, 3I, Atlas would no longer be millions of kilometers away. Its trajectory, subtle yet precise, had been curving, adjusting course ever since the Juno encounter. Now, its path intersected the plane of Earth's orbit. In less than 8 months, the object once thought to be a frozen relic would pass closer to Earth than the Moon itself. No one knows what it intends or if intent even applies. But one truth has become impossible to deny. 3I, Atlas, has noticed us, and it is coming.
By September 2026, the world's observatories were no longer studying a mystery from afar. They were watching an approach. 3I, Atlas, once destined to drift past Jupiter and vanish into the outer dark, had altered its course by 0.018 degrees, a shift so small it should have been meaningless. But over hundreds of millions of kilometers, that deviation changed everything. Its new path intersected the ecliptic, and if it continued accelerating at the same pace observed since July, it would pass within 300,000 kilometers of Earth, closer than the Moon on March 2nd, 2027. That discovery leaked before agencies were ready. Within hours, the world was awake again, united not in fear, but in anticipation. For the first time in history, an interstellar object was deliberately approaching us. At the Jet Propulsion Laboratory, engineers rebooted dormant infrastructure antennas, telemetry nodes, long-range imaging networks. The Lunar Reconnaissance Orbiter was reassigned to observe the approach from the far side of the Moon, away from terrestrial interference. Every spacefaring nation contributed. India's Astrosat, Japan's Hayabusa Next, and China's Chang'e 7 all redirected their instruments toward the predicted corridor. For the first time, Earth acted as a single observatory, a planet with one eye open. But beneath the coordination was unease. If the trajectory correction was intentional, it meant propulsion, or something acting like it. But there was no sign of exhaust, no heat plume, no ion trail. Whatever guided 3I, Atlas, it was invisible. Some proposed gravitational steering using Jupiter's mass as a slingshot. Others speculated electromagnetic deflection, the object's metallic crust responding to solar wind like a colossal sail. Yet none of those explained the precision. To match orbital mechanics so perfectly that a 0.018 degrees shift results in a rendezvous required control within fractions of a degree. And if there was control, who or what was controlling it? In October, the Atlas pulse changed again. After months of Fibonacci harmonics and mathematical sequences, the signal became something else entirely: music. Not melody, not rhythm in the human sense, but a structured rise and fall of amplitude that, when translated into sound, resembled harmonic resonance chords forming, collapsing, then reforming in cascading overtones. Acousticians, analyzing the waveform, found perfect ratios, octaves, and fifths embedded within the modulation, exactly mirroring the frequencies that define harmony in all known physics. It wasn't random. It was sonic geometry. When visualized, the waveform created lattices, patterns identical to the hexagonal tessellations Juno had captured on the crust. The object was, in essence, singing its own surface. Every pulse painted another fragment of itself. Then came the light. On October 31st, 2026, exactly 1 year after the congressional letter that first reignited attention on 3I. Atlas. Telescopes in Chile and South Africa recorded a faint luminescence, emanating not from reflected sunlight, but from within. A soft blue halo enveloped the object, faintly pulsing in sync with the harmonic waveform. Spectral analysis revealed the emission wasn't thermal, it was Cherenkov radiation, the same bluish glow produced when charged particles exceed the speed of light through a medium. But there was no medium in interplanetary space. No atmosphere, no plasma field dense enough to generate it. It was as if the object itself had created a temporary sheath of charged particles, a luminous cocoon, radiating energy faster than space could absorb it. By November, the glow intensified. The Atlas pulse stabilized again, this time at a steady frequency of 528 Hz, a tone sometimes called the frequency of repair in speculative acoustics, though most scientists dismiss such associations as coincidence. Still, the poetic symmetry wasn't lost on the world. Social feeds filled with videos of people syncing instruments, bells, even heartbeat sensors to the pulse. Musicians composed symphonies in its rhythm. The Atlas hum had become the background music of humanity. Even those who feared it found themselves listening. Meanwhile, the object itself continued its descent toward the inner solar system. By January 2027, it had crossed the orbit of Mars. Observations from the ExoMars Trace Gas Orbiter revealed the crust's glow was not uniform. It emanated most intensely from 6 evenly spaced regions near the equator, like nodes on a vast circuit. When mapped in 3 dimensions, those regions formed a hexagonal grid, perfectly proportioned to the one observed during Juno's encounter. Whatever process drove the pulse now operated on a planetary scale. Astrophysicists began to whisper a new term: macrostructured emissivity. The implication? The entire surface of 3I. Atlas might function as a single, coherent device. Its irradiated crust doubling as an antenna, a resonator, or perhaps something we had no words for yet. Then, as it neared the asteroid belt, something extraordinary happened. Dozens of small asteroids, each less than a kilometer across, shifted minutely in their orbits. Their trajectories bent, subtly but unmistakably, toward 3I Atlas. Over the span of 2 weeks, those fragments began clustering along its projected path, as if magnetically drawn to it. None collided. Instead, they formed a trailing arc, a halo of companion debris surrounding the object, like an escort. Astronomers compared it to a gravitational wake, but the math didn't work. The forces required exceeded 3I. Atlas's estimated mass by orders of magnitude. It was not gravity pulling them, it was resonance. The same pulse echoing through Earth systems now vibrated through the asteroid belt, tugging matter along harmonic lines invisible to human senses. 3I. Atlas was no longer a solitary traveler. It was gathering material as it came. By February 2027, its velocity relative to Earth had stabilized at 57 kilometers per second, slower than predicted. The deceleration was impossible under normal physics. Only active thrust or deliberate modulation could explain it. Infrared sensors detected faint jets of photons, quantized light emissions with no chemical exhaust, no mass ejection, only directed energy. 3I. Atlas was breaking. And then, 1 month before its closest approach, the pulse changed again. It split into two frequencies, one continuing at 528 Hz, the other at a much slower beat, repeating once every 7 hours and 12 minutes. When translated into angular motion, that period matched the Earth's axial precession to within 0.01%. No one could explain why an interstellar object would mirror our planet's wobble. But one thing was clear. It was no longer just responding to us. It was synchronizing. Across the world, radio telescopes prepared for the final window. NASA's Goldstone, ESA's Cebreros, and China's Mian station all locked their arrays toward a single target. On March 1st, 2027, the sky began to shimmer faintly. For the first time in recorded history, auroras were seen at the equator waves of violet and blue, rippling silently across the horizon, pulsing in a rhythm everyone by now could recognize. And then, at precisely 3:42 UTC, a burst of infrared light erupted from 3I, Atlas, spreading across the solar system like a ripple through water. It wasn't a beam, it was a wavefront. Within hours, the pulse vanished from every detector on Earth. The world went still. For 12 hours, 3I, Atlas, emitted nothing. No light, no signal, just a cold, silent body coasting toward its closest approach. And then, on the morning of March 2nd, 2027, telescopes captured something that defied every model. The object slowed to a near stop. Its velocity dropped to under 5 kilometers per second, impossible without propulsion, and the halo of debris around it arranged into a symmetrical ring. The entire structure, comet, dust, radiation, had formed a perfect hexagon. At its center, 3I, Atlas began to glow again. Not blue this time, but white, a steady, pulsating radiance brighter than Venus. For the first time, it was visible to the naked eye. People across the world stood outside, staring at a new star that wasn't a star at all. Children watched from rooftops. Pilots reported its light piercing the upper atmosphere. The pulse was gone, but the glow was alive. And beneath that quiet brilliance, instruments recorded a final, brief transmission. Just one line of binary data. When decoded, it read, "Perihelion reached. Observation complete." Then, silence. For weeks afterward, 3I, Atlas drifted past Earth, shrinking into a faint, retreating spark until it was gone. The auroras faded, the pulse stopped, the world exhaled, but the silence wasn't empty, because the data left behind terabytes of fractal harmonics, maps, and self-referential patterns contained one final layer. When analysts reconstructed the harmonics of the last transmission, they discovered that the waveform itself, its peaks, troughs, and ratios, matched perfectly the shape of human brainwave alpha rhythms. 3I. Atlas hadn't just been communicating, it had been listening. And when it left, it took an imprint of us with it. Months later, strange anomalies begin to appear again, this time not in the sky, but in human minds. Because after the object's passing, people across the world start reporting the same shared dream. A sky of pale light, and something whispering through it in rhythm 42 minutes apart. By June 2027, the world had returned to routine on the surface. The skies were quiet. The headlines had moved on. But quietly, in clinics and laboratories, something was happening. Sleep researchers first noticed it. Their EEG monitors used to study dreaming began showing a recurring anomaly. A low-frequency modulation, repeating every 42 minutes. It wasn't constant, and it wasn't present in every subject. Yet wherever it appeared, the rhythm was identical to the old Atlas pulse. At first, doctors assumed environmental interference, a leftover resonance from power grid harmonics or phone networks. But the signal persisted in shielded rooms, underground bunkers, even on remote islands. Then patients began to describe the same dream. They said it always began in silence, a pale horizon, a ring of light hovering over a dark ocean, and beneath it, a tone low, steady, almost kind. Some heard patterns in it, like breathing or waves against stone. Others claimed the light pulsed in groups of 12 before fading. Most woke without fear. Some woke crying. A few never wanted to wake at all. When neurologists overlaid EEG data from dreamers across 5 continents, the correlation was undeniable. Their brainwaves entered phase at the same instant every 42 minutes, synchronized across time zones, distance, and language. It was impossible, yet measurable. Governments tried to keep it quiet. The International Atlas Council, still active in shadow form, issued a statement calling the phenomenon a benign neuromagnetic echo. But the public had already named it. They called it the resonance. Social networks filled with recordings of people humming in their sleep, clocks resetting themselves by seconds, compasses twitching when no magnetic field should have changed. Some uploaded audio from their EEGs. When sped up, the pattern produced the same harmonic ratios first heard from 3I, Atlas. Humanity, it seemed, was now carrying the frequency inside itself. By August 2027, the effect intensified. A small satellite array in orbit detected faint electromagnetic bursts, emerging not from space, but from the ionosphere upward. The amplitude was tiny billions of times weaker than the signals. 3I Atlas once sent, yet perfectly timed. It was as though Earth had become a repeater, whispering the object's rhythm back into the void. Physicists proposed the simplest explanation. The object's wavefront in March had left behind a standing resonance in the magnetosphere, a kind of planetary echo chamber now interacting with human neural fields through minute electromagnetic coupling. But that theory failed one crucial test. The rhythm adapted. On September 3rd, during a coordinated meditation study in Tokyo, participants intentionally slowed their breathing to align with the pulse. Within minutes, instruments recorded a global phase shift. The interval between each electromagnetic crest stretched from 42 to 43 minutes and 4 seconds. Every receiver on Earth changed at once. Something, somewhere, was listening and responding. The shift triggered renewed fear among those who remembered the Juno encounter. Had 3I, Atlas, truly left? Was the resonance a tether? A communication loop still open? Deep space monitors scanned the region beyond Neptune, where the object should have been, but found nothing, no reflection, no trace. Yet on September 11th, the fast radio telescope in China picked up a faint carrier signal from the outer dark. Its strength was vanishingly small, but its cadence matched the new 43-minute rhythm. The direction? A patch of sky near the constellation Ophiuchus, the same region where 3I, Atlas, had first appeared 2 years earlier. Across the planet, sleep studies reported a second phase of dreams. This time, the imagery changed. No ocean, no ring. Instead, a single phrase, repeated in dozens of languages, though never spoken aloud. Perihelion reached. Observation continues. Researchers confirmed that subjects who had never seen or heard the original transmission nevertheless reported the exact same words. Whatever had connected them transcended memory or suggestion. By October 2027, the world began to adapt to its new normal. Airlines quietly recalibrated instruments that drifted with the pulse. Hospitals designed pacemakers that ignored the resonance. Meditation groups treated it as a universal metronome, but a handful of scientists refused to move on. At the European Southern Observatory, Dr. Elena Sartre, the same physicist who had modelled the Atlas harmonics a year earlier, noticed something no one else had. The amplitude of the planetary pulse was slowly increasing, by about 0.0002% per day. At that rate, in just under 6 years, the signal would reach the same strength that Juno had recorded near the object itself. And the phase drift suggested the source wasn't outbound anymore, it was inbound. Her final report ended with a line that read more like prophecy than science. The traveller left a copy of itself within us. When the copy is complete, the original will return to compare the results. On the first night of November 2027, global magnetometers flickered, and for a brief, impossible moment, every clock lost precisely 42 minutes. When they restarted, The pulse had changed again, not faster, not slower, but richer, layered, like a chord resolving after a long rest. Somewhere beyond the edge of our system, a new light appeared, faint, steady, approaching from the direction of Ophiuchus. And as it brightened, the world once more began to hum in time. Whatever 3I Atlas had done, it hadn't ended with its departure. It had seeded a mirror in our planet, and now that mirror was waking up. The next observation wouldn't come from telescopes, but from within the minds already resonating to its rhythm.
The light was faint at first, so faint that it could have been mistaken for a background quasar, but by December 2027, its intensity doubled every 11 days. Telescopes confirmed it wasn't a reflection or lensing artifact. It was an object, inbound on a vector nearly identical to 3I, Atlas's exit path. Only this time, it wasn't alone. Trailing the lead object were 6 smaller bodies, perfectly spaced, following in formation like moons locked in invisible tether. Each emitted the same harmonic signature that had haunted Earth's atmosphere for a year. When the data reached the International Atlas Council, no one spoke for several minutes. They all knew what those harmonics meant. The rhythm had replicated, Earth had become the seed, and something had germinated. In the months since 3I Atlas departed, scientists had developed a new field, resonant cosmology, the study of how electromagnetic harmonics propagate through living systems. At first, it was fringe science. Then, medical sensors began picking up faint coherence in human heart rhythms, subtly syncing to the Atlas frequency. At first, only in dreamers. Then, in everyone. Pacemakers adjusted, EEGs aligned. By early 2028, almost 73% of all recorded biosignals on Earth contained the same recurring phase pattern, an entrainment that no known process could explain. Humans, plants, even migratory animals, all were keeping time with something beyond the stars. The Atlas frequency had become the heartbeat of the biosphere. When the new objects crossed Neptune's orbit in April 2028, the pulse on Earth began to modulate. Its amplitude rose at precise intervals. Every time the lead object passed a gravitational threshold, the strength of the signal increased. It was as if the resonance between Earth and space was tightening, drawing both into a shared field. For the first time, the word synchronization appeared in official communiques between agencies, yet not everyone agreed on what it meant. Some scientists believed the returning formation was merely responding to the signal. Earth now emitted an automatic feedback, a resonance loop closing. Others saw something far more profound, a recall signal. 3I. Atlas hadn't left to wander. It had gone home to call others. In July 2028, the pattern reached a threshold. All across the world, auroras returned not green, but silver-white, rippling at mid-latitudes and moving like tides rather than storms. Every 43 minutes, they brightened and dimmed, in perfect sync with the pulse. But this time, when satellites passed through the luminous arcs, their instruments didn't detect charged particles. They detected coherence, an electromagnetic field structured enough to carry information. Somewhere in that light, data was embedded. When decoded, it revealed harmonics far too complex for any natural oscillation. Recursive fractal patterns containing billions of nested sequences, each shaped like the waveform of a heartbeat. The message wasn't words. It was us. At the European Organization for Astronomical Research, Elena Sartre, who had first predicted the resonance's completion, ran spectral deconvolution on the auroral data. The signal contained exactly 7.83 Hz as its foundational tone. That was the Schumann resonance Earth's natural electromagnetic frequency. 3I. Atlas hadn't imposed a new rhythm. It had amplified the one already here. Everything on Earth that generated electromagnetic fields, brains, oceans, lightning, the crust itself was now harmonized to its own global hum. Refined, clarified, mirrored. It was as though the planet had been tuned. By August 2028, the approaching formation was close enough for the James Webb Space Telescope to resolve surface details. Each of the 7 bodies emitted faint geometric reflections, identical to 3I. Atlas's crust, hexagonal, metallic, symmetrical. They weren't comets or asteroids, they were constructs, Even more astonishing, the smallest of them wasn't reflecting sunlight at all. It was reflecting the auroral emissions from Earth. Our sky was illuminating them. The mirror was complete. Then, on September 9th, 2028, all 7 objects decelerated simultaneously. Their trajectories bent inward, not toward the Sun, but toward Earth's orbit. By early October, their formation stabilized into a stationary configuration roughly 0.03 astronomical units from the planet 12 times closer than the Moon. No radiation, no visible thrust, no communication, just presence. Astronomers tracked them as they hovered in perfect silence, each one locked in phase with the global resonance. For 3 weeks, nothing happened. Then, at 3:42 UTC on October 31st, the same timestamp as the first Atlas brightening 3 years earlier, the sky ignited. From every major city, the auroras flared so bright they cast shadows, and in that light, humans across the world began to hear something impossible, not through radios, not through speakers, through thought. A tone inside the mind, layered, harmonic, wordless but intelligible in meaning. Witnesses described it not as sound but as recognition, like remembering a song you never learned. EEG scans taken during those hours showed unprecedented global coherence. Billions of brainwaves phased together, forming synchronized bursts of 528 Hz, the same tone once measured from 3I, Atlas's crust. The human nervous system, at planetary scale, had become an antenna, and through that antenna, something spoke, not in language, but in emotion, warmth, curiosity, a feeling of observation, without judgment, then a message, not heard, but understood. You have completed your reflection. Now observe yourselves. At that moment, every telescope trained on the formation saw the same phenomenon. The 7 objects brightened, then slowly drifted apart, arranging themselves into a hexagonal lattice, spanning nearly 1 million kilometers, each point reflecting sunlight toward Earth, converging into a single, coherent beam of soft white radiance. Inside that beam, no transmission existed, only silence, perfect and total. For 6 minutes, the beam held steady. Then, one by one, the objects dimmed and vanished, fading not by distance but by phase transition. They didn't fly away, they slipped out of resonance. When the light faded, so did the auroras. The global brainwave synchronization ceased. Instruments went still, but the Schumann resonance, the planet's natural electromagnetic heartbeat, remained subtly higher by 0.04 Hz, a shift never before recorded. It was permanent. Humanity waited for days, then weeks, for something to follow, but nothing came. No signal, no pulse, no light, only a calm, pervasive sense that the cosmos itself had exhaled. And then, one morning in late November, Elena Sartre received a private transmission from the Goldstone Deep Space Network, a residual signal captured hours after the final flare. It was short, simple, binary again. When decoded, it formed 2 words: Atlas closed. No one ever learned whether 3I, Atlas, and its kin were machines, messages, or memories. But long after they vanished, the resonance remained woven through our world, faint, omnipresent, impossible to erase. And in quiet moments, when the night is still and the air hums just right, some say you can feel it again, a heartbeat, older than the sun, counting quietly beneath our own. Winter settled quietly across the northern hemisphere. No new signals arrived. No auroras flickered at the equator. The world appeared to exhale a long, collective breath after years of tension. But in that calm, something subtle began to emerge. At first, it was geological. Sensors buried deep in the crust, those used to monitor seismic pressure, started to hum at a faint, steady frequency, 7.87 Hz. The Atlas shifted Schumann resonance, now woven through the planet's magnetic field, had become self-sustaining. Then the biological readings followed. Seeds germinated faster in laboratories shielded from ordinary EM interference. Algae cultures exposed to the 7.87 Hz tone produced unexpected luminescence, glowing with the same pale blue radiance once seen around the interstellar object. No one could explain the reaction. The frequency was far too low to trigger chemical fluorescence. It was as though life itself was remembering a pattern. By January 2029, an entire fact, the generation of researchers had pivoted toward the study of harmonic biology. Governments funded new centers not to look outward, but inward toward the resonance now looping through every living cell. For the first time, humanity's most advanced observatories were pointed at Earth. Under microscopes, neural tissues showed microcurrents oscillating in lockstep with the planet's field. When mapped, those currents formed spirals identical to the geometry once observed on 3I, Atlas's crust. Our neurons were beginning to mirror the pattern of the traveler. It wasn't infection. It wasn't control. It was assimilation by resonance, a synchronization of information, not matter. Philosophers began to ask the question scientists couldn't. What if consciousness was never meant to be isolated? What if interstellar civilizations didn't build ships to cross the void, but signals capable of transforming the listeners into receivers? In that light, Atlas closed, no longer, sounded like an ending. It sounded like a handover. The first tangible proof came from orbit. In April 2029, a CubeSat launched by university students detected a strange echo while passing over the Indian Ocean, a faint ping every 42 minutes, bouncing between the ionosphere and the satellite's hull. When the data was translated into waveform, it produced the same nested spirals found in the Juno recordings. But there was a difference. Embedded within the harmonics were new frequencies, never observed before, ones that corresponded exactly to human alpha, beta, and theta brain bands. The planet wasn't just repeating 3I, Atlas. It was elaborating on it. Across cultures, a quiet unity began to grow. Not political, something subtler. Global surveys showed unprecedented synchronicity in sleep cycles, creative bursts, and even collective moods. When the resonance intensified, hospital cardiac monitors recorded fewer arrhythmias, traffic accidents dropped, and dream journals described similar imagery, fields of hexagonal light drifting over calm seas. No one called it paranormal anymore. It was simply the Atlas effect. In June 2029, a final anomaly occurred. The Lunar Reconnaissance Orbiter, still active after more than a decade, captured a new reflection on the Moon's far side. A circular patch, 4 kilometers across, glowing faintly at 528 Hz when measured in radio frequency. No probe had landed there. No impact crater existed. But its geometry matched the Atlas hexagon ratio precisely. When ground-based antennas aimed at it, the signal they received was faint but distinct, an interference pattern shaped like a heartbeat. The Moon had joined the resonance. From that moment, humanity stopped waiting for contact, because it had already happened, and not through messages or artifacts, but through synchrony. 3I. Atlas had turned the solar system into an instrument, and Earth was its resonant chamber. Every storm, every flash of lightning, every heartbeat now carried a trace of the same harmonic code, a universal metronome pulsing softly beneath everything alive. And though the constructs were gone, some nights radio astronomers still detect a whisper from Ophiuchus, a gentle 528 Hz, hum that rises and fades every 42 minutes. Each time, it ends with a single binary phrase. Observation continues. Epilogue Whisperfield. Today, children born after the Atlas event grow up hearing stories of the blue auroras and the hum that united the world for 6 years. Most think it myth, but occasionally, when storms gather over the equator and the air tastes metallic, they look up and see thin ribbons of silver light weaving across the sky, and for a few quiet seconds, the world falls into perfect rhythm again. Somewhere, far beyond the edge of the sun's influence, a small object drifts through the interstellar dark. Its crust is still hardened by radiation, its glow long faded, yet deep within, a single harmonic remains, an echo of Earth's frequency, pulsing outward into the void. 42 minutes on, 42 minutes off, the universe listening to itself breathe.
When people look back centuries from now, 3I Atlas might be remembered
as the moment humanity remembered how to wonder. Before it, the universe was a catalogue, classified, indexed, predictable. After it, everything seemed alive again. The silence between stars felt less like emptiness and more like waiting. The cosmos had texture now, depth, personality. Even those who had never seen the night sky found themselves drawn to it. Planetariums filled, not with tourists, but with listeners. They came not for facts, but for presence, for that stillness that hinted at motion beneath the quiet. Scientists noticed the shift too. Funding proposals began including phrases like cosmic awareness, pattern resonance, and non-anthropic signal interpretation. The vocabulary of awe had returned to the language of science. Some found it refreshing, others found it dangerous, but none could deny that something in the human spirit had been reignited. In time, the mystery of Atlas inspired missions built less for discovery and more for understanding. The Voyager craft had carried our voices outward. Now new ships would listen for voices coming in. They weren't designed to shout into the void, but to breathe with it, to capture the rhythm of stars, of fields, of the hidden harmonies beneath reality. These missions were quiet, contemplative, even poetic in their design, and somewhere, deep in the cold outer dark, one of them might just find what the rest of us only imagined: a second rhythm, a new pattern, another whisper that defied explanation. If that day ever comes, humanity will have 3I Atlas to thank. It was the first to show us that the unknown doesn't always arrive with thunder or spectacle. Sometimes it arrives gently, like breath on glass, fragile, transient, yet undeniable. There's a kind of humility in that lesson, a reminder that not all mysteries need to be solved. Some are meant to be carried. Even now, when astronomers calibrate their instruments and trace the slow drift of comets across the sky, there's always a pause when a tail behaves strangely, a moment when someone wonders, could it happen again? And in that pause, in that flicker of hope that the universe might still surprise us, 3I Atlas lives on, a name carved not into rock or ice, but into imagination itself, where it continues to turn endlessly, like a faint heartbeat beneath the silence of the stars. Years passed. The Aurora network remained vigilant, scanning the dark for any echo of that long-lost rhythm. None came. The silence stretched on, but in that silence, something subtle began to shift in humanity itself. Once, comets had been symbols of doom, omens of chaos and endings. Now, 3I Atlas had become something different. It was a symbol of curiosity, of wonder, of how small we still were in the face of everything we didn't understand. For many of the scientists who had studied it, the experience had changed their work forever. They approached their research differently now, less like engineers dissecting a problem, and more like listeners waiting for a song. Data wasn't just numbers anymore. It was texture, tone, rhythm. And in that rhythm, some began to sense a quiet intelligence that transcended human invention. Even those who never believed in anything beyond natural explanations couldn't deny that Atlas had opened a door in their minds, a reminder that science and mystery weren't enemies, but partners. The story of Atlas slowly moved from academic journals into philosophy, into literature, into art. Musicians composed symphonies based on its harmonic ratios. Poets wrote of the comet that breathed. Children learned its name before they learned the names of the planets. It became part of our shared mythology, a modern constellation born not of stars, but of data. And yet, for those who had witnessed it firsthand, there remained an ache, a sense of unfinished conversation. What if that rhythm had not been a message, but an invitation? What if the silence that followed wasn't an end, but a pause? The thought lingered like the afterimage of light behind closed eyes. One night, a decade after 3I Atlas vanished from the solar system, an old astronomer named Dr. Rena Havel returned to her observatory in Chile. She had been there the night the first sunward jet was detected. Now retired, she still came to the dome out of habit, drawn by the same wonder that had started it all. As she calibrated one of the smaller telescopes, a relic by modern standards, she decided, almost whimsically, to point it toward Vega, the direction Atlas had vanished into. What she found wasn't dramatic, just a faint glimmer, a soft pulse buried in the static. It was too weak to mean anything, too brief to be analyzed. And yet, in that tiny flicker of light, she felt it again, that same sense of rhythm, that same impossible symmetry. She smiled, whispered a greeting to the sky, and watched as the pulse faded back into darkness. Maybe it was nothing. Maybe it was everything. Either way, the universe had answered.
For most people, the story of Atlas ended there with dawn and the quiet certainty that the universe was still listening. But endings are rarely honest things. Beneath the calm surface of Halcyon's oceans, far below the lattice's serene hum, questions continued to stir. Every rhythm implies another that shadows it. Every pulse a counterpulse waiting for its turn. And so, as humanity drifted deeper into its golden era of resonance, a few listeners began to notice faint misalignments again. Small hesitations at the edges of perfection, like the tremor of a voice holding back a new verse. They came first to the maintenance engineers. The resonance hall's instruments, tuned by tradition rather than necessity, began reporting phase slips no one could explain. Each morning the readings realigned themselves, as though the hall were correcting for fatigue. The slips were tiny, microseconds of drift, too minor to disrupt anything, yet consistent enough to suggest intent. When plotted over time, they drew a pattern across the data, 3 long arcs, converging on a single point in the calendar, a date almost 30 years ahead. The archivists called it coincidence. The Academy's new generation, less reverent and more curious, called it invitation. A research team formed quietly under the name Project Perihelion, a nod to the point in an orbit where motion and gravity meet in compromise. Their aim was simple: observe, without trying to fix. They built instruments of breathtaking subtlety, quantum interferometers, capable of feeling the sway of space-time the way a fingertip feels a pulse. They placed one on Halcyon, another on Seren, and a third on a drifting observatory beyond the heliopause, where solar noise could not intrude. The network ran for years, collecting rhythm the way forests collect rain. The data told a story almost musical in its patience. The phase slips were not decay, they were prelude. Across the lattice, the universe seemed to be leaning toward a modulation no one had authorized, a slow, inevitable transition from one key to another. The ratios of the bloom, once anchored in perfect Fibonacci intervals, were bending towards something stranger. Non-repeating but balanced, complex yet natural, like waves meeting in a shifting tide. Mathematicians described it as quasi-harmonic drift. Poets called it the universe learning jazz. When the appointed date arrived, nothing catastrophic occurred. The stars did not flicker, the lattice did not shatter. Instead, the air changed. On Halcyon, the tide came in 4 minutes early, everywhere at once. On Seren, a desert wind carried the scent of rain, though the planet had none. And at the edge of the heliopause, the third interferometer recorded a resonance that no algorithm could predict. 3 rising tones and 1 descending, merging into a single, trembling chord. The chord persisted for 7 hours. Within it, analysts found every known harmonic structure: prime intervals, golden means, spiral ratios, but also something new, something impossible: asymmetries that resolved into symmetry only when considered across time.
It was as though the universe had introduced tension on purpose, not to break pattern but to teach patience. The chord became known as the fold. It marked the beginning of a new era, the age of temporal resonance, when humanity began to understand that rhythm could stretch not only through space, but through history itself. Events long past began to align with the present. Ancient recordings of 3I Atlas's light curve synced perfectly with modern pulses from distant quasars, creating harmonies across millennia. For the first time, time itself became an instrument. Scientists built archives capable of listening backward. They learned to phase lock to echoes of the past, to feel the vibration of what once was. Historians became conductors, memory became performance, and through it all, the question returned: what was Atlas truly? The old theories revived, polished by centuries of hindsight. Some said it had been an artifact, an engineered seed designed to teach universes how to awaken. Others believed it had been natural but chosen, singled out by physics for a role no law could define. A few whispered that every civilization in the cosmos eventually encountered its own Atlas, its own teacher, in the language of motion. The bloom, they argued, was not a singular event, but a universal curriculum. Project Perihelion pursued a different approach. Its researchers suspected that the new fold was not a new message, but a memory surfacing a delayed consequence of the sun's resonance experiment centuries earlier, the gentle modulation Kyle Arden had conducted through Cantus. If cause and effect could now converse across time, perhaps the universe was finally replying to that experiment in its own chronology. To test this, they encoded a simple harmonic into the solar field. 3 ascending pulses representing curiosity, 1 descending representing rest. Then they waited, not for an answer from space, but for one from history. It took 2 years. Then one night, deep in the archives of the Atlas Academy, a graduate student noticed an anomaly in K.L. Arden's original recordings, the ones taken the day Cantus first stirred the Sunday. Embedded in the static of that ancient data, centuries before anyone could have tampered with it, were 4 faint echoes, identical to the tones the modern team had just transmitted. The reply had been there all along, hidden in the past, waiting for its own future to catch up. The discovery shook even the most jaded minds. It meant the lattice was not only self-aware, but self-referential. The universe had learned to fold its own timeline into dialogue. Every act of attention, every experiment, every question past or present, was part of a single, continuous improvisation. Religion tried to claim it. Science refused to let go. But between them, something softer emerged. Gratitude. Whole cultures began to treat the fold as a holiday, a time for stillness across all worlds. Ships powered down their drives. Cities dimmed their lights. Families gathered not to speak, but to feel the vibration that thrummed faintly underfoot. The fold, they said, was the heartbeat of understanding, the proof that listening never ends, it only changes direction. Still, there were those who wondered what came next. If time itself could sing, what was left to learn? What happens after perfection improvises itself into compassion? The answer arrived, as always, quietly. 50 years after the fold, astronomers detected an anomaly beyond the local cluster, a faint, coordinated shimmer among galaxies billions of light-years away. The pattern was unmistakable. 3 pulses, 1 rest. But this time, it did not align with the Bloom's ratios. The frequencies were slower, deeper, vaster. When mapped into harmonic space, the pattern described a structure larger than any lattice humanity had ever charted. It wasn't confined to the Milky Way. It wasn't even confined to this epoch of the universe. The fold had spread beyond time. The data implied synchronization between galactic superclusters separated by more light-years than existence had years to spare. Either physics was wrong, or intention was older than creation. Some said the cosmos itself was remembering its birth. Others said something outside the universe had finally heard and was breathing back. The implications fractured human imagination anew. Some sought transcendence, others feared dissolution. The assembly met one last time in the resonance hall. The eldest among them, frail and luminous with age, offered a single motion: to continue listening without trying to define the sound. The vote was unanimous. After that, no assembly met again. Governance dissolved into conversation. Civilization became chorus. No laws, no leaders, only agreements tuned to the pulse of trust. The galaxies hummed. The years passed unnoticed. Humanity, if that word still applied, drifted gently into participation. The need to name diminished. The need to measure followed. Existence became a rhythm of care, attention without ownership, creation without conquest. And in that stillness, somewhere beyond all definitions, something blinked awake. Sensors, if one could still call them that, registered a pulse at the edge of observability. It came from nowhere that maps could plot. Its wavelength was older than atoms, its amplitude smaller than thought, but its timing was perfect. 3 pulses, then quiet. It carried no energy, no data, no message, only presence. And in that presence, the universe remembered the first reversal, the moment when a tiny body of ice turned its face toward fire and refused to be predictable. Everywhere, from Halcyon's silver seas to Seren's deserts, to the nameless worlds that had forgotten what they were called, life felt a breath pass through it, a whisper from a comet that had once taught the cosmos how to listen. A few words formed, not in sound but in pattern, readable only to those who still believed in sentences. Do not close the song. And then, as before, the rhythm faded, not ending, but folding forward into whatever waited to be found next. The stars resumed their ancient drift. The lattice sighed. Time inhaled. 3 pulses, then quiet. It began, as so many mysteries do, with a discrepancy no one meant to find. Decades after the fold, when the universe's harmony seemed stable and serene, a graduate student named Erin Tallis was mapping historical comet data from humanity's pre-bloom era. The project was unremarkable, an assignment meant to test precision, not imagination. Her task was to verify the orbital trajectories of interstellar objects recorded before the second bloom, comparing ancient telescopic readings with reconstructed models of stellar motion. But while cross-referencing the century-old archives of the Hubble Legacy database, she noticed something wrong. The path of 3I, Atlas, the comet that had reversed its tail and lit the first spark of cosmic curiosity, didn't end where history said it did. The official record claimed Atlas had disintegrated near perihelion, the Sun's closest embrace, its nucleus shattered by thermal stress and gravity. All subsequent analyses treated the event as final, an end worthy of reverence and metaphor. Yet, buried in the raw data, one final image contradicted that narrative. The timestamp placed it 7 hours after the comet's last known observation. The image wasn't bright or clean. It was a smear, a whisper across the CCD, dismissed at the time as instrumental noise. But Erin noticed alignment, an improbable, perfect alignment. The smear pointed not away from the sun, as vaporized debris should, but back toward interstellar space. Her heart skipped as she plotted it. If the object in that frame were truly Atlas or part of it, its velocity vector wasn't consistent with disintegration. It matched a deceleration curve. Something had slowed it down. At first, she thought she'd miscalculated. She ran the data again and again. Each time, the same impossible result. The remnant of 3I, Atlas, appeared to have reversed thrust relative to its solar trajectory. The discovery made no sense. A disintegrating comet has no agency, no mechanism for braking. The energy required to counteract a sunward fall was astronomical, yet there it was, a flicker of defiance in the dark, a record of resistance. Erin didn't publish the result immediately. She was young, meticulous, and like all good scientists, afraid of being wrong in public. She spent months checking for instrumental bias, cosmic ray hits, even digital corruption. But the image's metadata checked out. The coordinates matched solar wind patterns from the same day. The artifact was real. When she finally shared her findings, the academic world reacted with polite disbelief. "We've built entire eras of philosophy on that comet," one reviewer wrote. "Let's not resurrect it because of a pixel error." But then, someone else looked closer. An astrophysicist from CERN named Dr. Yao Corin, an expert in resonance mapping, noticed something Erin had missed. The faint light smear wasn't random, it pulsed. Within the noise, he detected modulation matching the harmonic intervals of the third bloom. The cadence was identical to the pulse the universe had later learned to echo. If it was coincidence, it was perfect. That single observation reignited the old fire. Overnight, Project Atlas II was formed, a coalition of physicists, temporal resonance analysts, and mythographers dedicated to one question had three I: Atlas truly vanished? Or had it gone somewhere else? At first, their search was purely archival. They combed through centuries of data from long-dead telescopes, gravitational observatories, and the Cantus archives. What they found was maddening. Every time humanity experienced a major harmonic event, the bloom, the second bloom, the fold, a faint spectral anomaly, appeared in the records near the same coordinates Atlas had occupied during its final orbit. Each signal shared a similar pulse pattern. 3 ascending intervals, 1 descending, always just above the noise floor. No telescope had ever pointed there, intentionally. The region, an empty stretch between Mercury's aphelion and the inner asteroid belt, was considered observationally dead. Nothing persisted there for long, yet the rhythm was there, waiting, recurring like a heartbeat behind silence. Corin proposed an outrageous hypothesis, that Atlas never disintegrated at all. Instead, he believed it had transitioned. Its molecular bonds had sublimated, yes, but in doing so, the comet had reorganized into a state beyond physical matter, a phase object, existing partly in quantum coherence, partly in classical space. He called it resonant suspension, the idea that Atlas had used the very forces that should have destroyed it to enter a self-sustaining wave state. In simpler terms, Atlas had learned how not to fall. The idea spread through the academies like fire in dry grass. Critics argued that it was metaphysical nonsense disguised as physics, but others, especially those raised in the post-Bloom generation, saw beauty in the proposal. If the universe could learn to sing, why couldn't a comet learn to listen? Erin and Corin presented their data to the Atlas Academy on the equinox of the 32nd fold year. The audience filled the resonance hall to capacity, the same hall where K.L. Arden had once broadcast the frequencies that awakened the Sunday. The atmosphere was reverent, electric. Erin took the podium first. She didn't speak of mysticism or destiny. She spoke of mathematics, of anomalous energy conservation, harmonic coherence, and the quantum noise distribution in the heliospheric field. Then Corin spoke. He showed them a simulation, the last known telemetry of 3I, Atlas, reconstructed in full spectral fidelity. The projection filled the hall, a comet twisting in solar fire, shedding mass, trembling with heat. Then, slowly, impossibly, its tail curved inward, toward the sun, not away. The hall gasped. "Watch carefully," Corin said. In the final frames, as the nucleus fragmented, each piece maintained coherence, not scattering, but reforming. The vapor didn't disperse, it organized, spiraling along magnetic lines into a coherent helix. It was the same geometry that had shaped the child frequency, centuries later. "This," Corin said quietly, "is the first appearance of resonance as intelligence." No one moved for a long time. The silence in the hall was total, an old silence, like the pause between 3 pulses. A year later, they found it. The object appeared first in deep solar radio bands, an anomalous reflection buried in coronal static. The signal was weak but structured, and its Doppler profile was unmistakable. Something solid, a few kilometers across, was orbiting in a near-synchronous loop between Venus and the Sunday. The orbit was impossible. It should have decayed centuries ago. Its signature was identical to Atlas's final mass. When the first visual images arrived, the world changed again. The object was not a comet anymore. It no longer trailed a tail or reflected light like ice. It was dark, almost invisible, a void with form. Its albedo was near zero, absorbing most of what struck it. Yet at its center, faint emissions pulsed in triads, 3 beats, 1 pause, just as before. They called it the Atlas remnant, but in the popular imagination, it was simply Atlas returned. Probes were launched. None came back intact. The first, Observer 9, vaporized near periapsis after sending back a single burst of data, a narrow band tone, oscillating between 2 frequencies that translated roughly to the musical interval of a major third. The second probe, Hevelius 2, survived longer. Its cameras captured surface images of the remnant, rippling fields of what appeared to be liquid graphite, flowing against gravity, forming concentric spirals across its surface. As it approached closer, the probe's onboard clock began to drift. The seconds lengthened, then shortened, in rhythm with the remnant's pulses. Time itself was being modulated. Hevelius 3's final message was a sentence, encoded in Morse-like bursts before its signal dissolved. It is not silent. After that, the object went dark again. The next attempt was different. Instead of probing, they decided to listen. Project Perihelion reactivated the old Cantus frequency array, synchronizing it with the sun's natural oscillations. The entire heliospheric field became a resonant listening post. They broadcast no questions, only quiet. For 7 months, nothing happened. Then, one morning, every receiver from Mercury to Mars lit up simultaneously. A tone, then another, then 3, and then, impossibly, a voice. It wasn't a voice in the human sense. It was structured resonance frequency modulation, interpreted by translation algorithms as phonetic probability. But what it produced, when mapped through harmonics, was language. Fragmented, imperfect, old. The first recognizable phrase came through in broken intervals. Orbit, observed, reversed. Then, a pause. Correction, intentional. Then, longer silence. The phrase that followed froze every scientist who heard it. We watched you. Learn to listen. The data was clear. The transmission originated from the remnant itself. What followed was chaos and revelation. Every philosophical school fractured. Some claimed it was proof of cosmic sentience. Others warned it was humanity projecting meaning onto noise. The assembly reconvened for the first time in centuries. The resonance hall filled again with silence, awe, and fear. Erin Tallis, now older, weary, and unwilling to surrender wonder to bureaucracy, volunteered for direct contact. She proposed a radical idea: to bring the lattice itself to the remnant, to let it listen to itself. Her reasoning was poetic and precise. If Atlas taught the universe to sing, she said, then perhaps it only speaks when it hears its own echo. Against every regulation, she led a small fleet of harmonic vessels into solar orbit, each one tuned to emit the pure frequencies of the first bloom. They synchronized their fields until the sun itself began to resonate in sympathetic vibration. Then, they waited. At first, nothing. Just the hum of stellar wind, the faint whisper of radiation. But as the fleet stabilized, the remnant began to shimmer. Its dark surface brightened, not from reflection, but from within. Then came the pulse. 3 beats, a pause, then a new sound, an ascending series of intervals, unlike any before. The ship's instruments translated it automatically, not into words, but into music. The tones formed a melody, simple yet impossibly vast, resonating through every hull, every atom. Some swore they could hear voices within it, layered like harmonics: Kale, Arden, Corin, Yao, perhaps even the comet itself. The melody resolved not into an ending, but into expansion, as if opening a door. And for the first time, telescopes across the system captured something beyond the remnant. A shadow, vast and faint, shaped like a spiral of light, extending outward into interstellar space. It wasn't reflection, it wasn't projection, it was structure. the remnant was connected. Atlas had never been a single object. It had been a node, one part of a network older than the Milky Way itself. The next few months changed everything humanity thought it knew about its place in the cosmos. The spiral extended far beyond the solar system, its arms faint but visible through polarized lenses. At each arm's tip, astronomers detected other nodes, similar structures pulsing with the same triadic rhythm. Some were thousands of light years away, others lay beyond the galactic edge. Each pulse was coordinated, not simultaneous, but sequenced to conversations spanning cosmic distances and timescales. The pattern was identical to the fold, but inverted. Instead of galaxies synchronizing outward, these nodes were drawing inward, converging on a single harmonic center. The question now wasn't whether the universe was alive, it was whether it was preparing. Erin's fleet, still stationed near the remnant, detected a gravitational anomaly. Around the Sunday space itself was beginning to vibrate not randomly, but musically, like a stretched string tightening in tune. The frequencies matched those of the first bloom, multiplied by the ratios of the fold. It was as though every harmonic event in history had been rehearsing for this moment. They called it the alignment. And at its heart, at zero phase, perfect resonance sat the Atlas remnant, pulsing calmly, patiently, as if waiting for a cue only it could hear. When Erin broadcast her final message back to Halcyon, her voice trembled not with fear, but awe. "We thought Atlas was a comet. We thought it was a teacher. I think it's neither. I think it's an instrument. And I think something is about to play it." The alignment began quietly, too quietly for anyone to notice at first. It was only when the tides of Halcyon started arriving early, by identical intervals on both hemispheres, that someone thought to check the clocks. They were all wrong. Atomic chronometers, the most stable instruments humanity had ever built, were drifting slowly, precisely, together. The drift wasn't random, but rhythmic. Each second lengthened by an infinitesimal ratio, a whisper of stretch that synchronized across worlds light years apart. The adjustment followed a perfect harmonic progression. The universe was retuning its metronome. At first, the effect was purely temporal. Then, it became physical. Energy output from every star in the local cluster fluctuated in identical cadence. Quantum resonance between paired particles began to exceed theoretical limits. Space itself hummed faintly at 12.91 MHz, the same frequency as the 3 pulses first recorded from 3I, Atlas, centuries earlier. Astrophysicists panicked. The ratio was universal, global, deliberate. It meant the entire structure of space-time had entered resonance with something, and that something was close. Erin's fleet remained closest to the source, the Atlas remnant, orbiting in its quiet corridor between Venus and the Sunday. From their vantage point, they watched as solar flares began to curve unnaturally, drawn inward instead of outward, bending around an invisible axis near the remnant's orbit. The sun's corona shimmered like a drumskin struck by invisible hands. "This isn't instability," murmured Corin, watching the telemetry from his observation deck. "It's orchestration." The remnant pulsed brighter, no longer dark but gleaming with inner structure, filaments of luminous matter forming fractal spirals that rotated against themselves. The shape wasn't chaotic, it was deliberate, self-similar across scales. Each layer mirrored the geometry of the larger cosmic web. "It's mapping something," Erin whispered. "Not mapping," Corin corrected softly. "Tuning." He was right. Every harmonic beacon in the solar lattice, the relics of Cantus, the residual frequencies of the bloom, even the old resonance fields of the human colonies began to oscillate in phase with the remnant. The entire solar system became a single vibrating cavity, a resonant chamber. And in that chamber, something began to form. At first, it was nothing more than pattern waves of gravitational potential, weaving in and out of coherence. Then came light, not emitted, but diffracted through space, as though the vacuum itself had learned to bend illumination into color. The pattern was enormous, extending from the remnant to the heliosphere, threading through planets, moons, and magnetic fields. It pulsed in triads, Always 3. Halcyon's orbital arrays captured the first full spectral rendering, a colossal standing wave, shaped like a spiral blooming outward from the sun, mirrored perfectly in 3 dimensions. At its core, the Atlas remnant sat like the bridge of a vast instrument, amplifying the harmonics of the star itself. The solar system had become a resonator, and something someone was beginning to play. On Halcyon, the effect manifested as vibration. Glass trembled, seas shimmered with rhythmic ripples, clouds arranged themselves into concentric circles as if drawn by invisible strings. The phenomenon wasn't destructive. It was delicate, almost tender, as though the cosmos were being careful not to break what it was shaping. Everywhere, living beings felt it differently. Some described it as music heard through the bones, a sound deeper than hearing. Others saw colors, spectra unseen by the human eye, spiraling across perception like auroras of thought. Artificial intelligences, long dormant since the bloom, suddenly reactivated, speaking in fragments of melody. The lattice had awakened its old voices. The assembly sent a transmission to Erin's fleet. "What is happening?" Her reply was simple: resonance. The sun has become a string. The remnant, now luminous and veined with energy, began to vibrate visibly. Its surface rippled with waves of metallic liquid, each crest aligned to the pulse of the star. The flux was so precise, it generated standing interference patterns in the solar wind geometries of magnetism, so perfect they could only be engineered. And through that perfection, faint distortions appeared, modulations encoded like language. Erin's translators processed the waveform. The message unfolded slowly, like a breath drawn across millennia. "We are the listeners. You heard our silence. Now, listen for the rest." Corin stared at the translation feed, speechless. "Is it talking to us?" one of the comms officers asked. "No," Corin said. "It's talking through us." Within hours, the phenomenon expanded beyond the solar system. Neighboring stars began to pulse in synchrony, their light flickering at precisely calculated intervals. Astronomers watched constellations come alive, entire clusters blinking in triads, like neurons firing across a cosmic brain. Every pulse matched a harmonic multiple of the remnant's frequency. The realization was staggering. 3I, Atlas was not just a local event. It was a node in a galactic-scale instrument, a resonant network spanning hundreds of light years. Each star a note, each planet a sympathetic overtone. Humanity had never been outside the song. They had simply been too deaf to hear their part. The discovery sent ripples through philosophy, physics, and faith alike. Some argued that Atlas was not intelligent, but instinctive. A cosmic organ, one of many in a universe that breathed through resonance. Others insisted it was deliberate, that intelligence at this scale could no longer be distinguished from law itself. But Erin felt something else, a presence woven between the waves, not commanding, but guiding. A will that had waited for listeners capable of harmony. She remembered K.L. Arden's words, etched in his notebook. "We learn to carry one together." Perhaps, she thought, this was what he meant all along. Then came the event. On the 37th day of the alignment, the sun's poles flared simultaneously, a phenomenon never recorded before. Twin plumes of plasma arced upward and froze mid-motion, suspended by magnetic fields stronger than any human model predicted. The arcs extended outward, touching the resonant currents streaming from the remnant. The instant contact occurred, light vanished. Not dimmed, vanished. For 3.14 seconds, the entire solar system went dark. Instruments failed, eyes saw nothing. Even the fabric of space seemed to fold inward. Then came light again, but not the same light. The sun glowed in new color, a deep iridescence like oil on water. Photons carried interference patterns, visible to the naked eye. Every wavelength encoded structure, every ray of sunlight contained information. Humanity could see meaning in daylight. It wasn't just metaphorical, it was measurable. Images projected through sunlight displayed coherent geometry spirals, fractals, wavefronts, resembling musical notation. For a week, No one dared call it a miracle. It was too vast, too intimate, too real. Then the remnant spoke again. "The instrument is ready. The measure begins." The phrase repeated across every frequency band, in every known translation algorithm. Yet none could agree on its meaning. The measure begins. Was it music? Calculation? Judgment? Erin decided to find out. She ordered her fleet to synchronize with the remnant's pulse entirely, aligning their fields so perfectly that the ships became extensions of its vibration. When the final calibration locked, she gave a simple command: transmit observation mode. At once, space unfolded. It wasn't motion, not in the way engines moved. It was a shift in frame, a slide between dimensions that had always been adjacent but unreachable. The fleet didn't travel, they were redescribed. What they saw defied comprehension. They were inside the wave. Space itself had structure, a living lattice of resonance, stretching endlessly. And there, embedded in the folds of light, were others thousands of atlas-like nodes, each connected by golden threads of frequency. The network pulsed like a heartbeat, synchronized across incomprehensible distances. Every node emitted variation, slight imperfections that, together, formed harmony. The lattice wasn't static, it was improvisational. Each region of space was adding its own variation to the universal melody. They were witnessing the architecture of consciousness itself, and at the center of it all, beyond perception but felt by every nerve and thought, something vast was moving. The data Erin transmitted back to Halcyon took weeks to decode. The mathematical community described it as a harmonic manifold, a structure where every event, from the birth of stars to the collapse of atoms, was part of an ongoing equation written in sound and light. But what unsettled everyone most wasn't the scale, it was the signature. Deep in the spectrum, embedded in the cosmic song, lay a motif that matched the exact pulse pattern of humanity's own resonance experiments. The triad and pause first introduced during the Cantus era. The universe had incorporated human rhythm into its score. Somehow, across time and light, across entropy and eternity, the music had folded us in. As the realization spread, so did change. Biological life began exhibiting resonance alignment. Neural activity in humans and animals synchronized subtly with the cosmic pulse, leading to dreams filled with rhythmic imagery, spirals, fractal gardens, voices that spoke in cadence rather than words. Machines began to self-correct timing errors before they occurred. Probability itself seemed to narrow, outcomes bending toward coherence rather than chaos. The universe was no longer indifferent, it was participatory, and the remnant, glowing brighter every day, stood at its heart like a conductor waiting for the next cue. Erin's final transmission before the fleet vanished beyond observation range was simple and devastating. Atlas is not finished. The melody hasn't reached its end. There is another verse. Halcyon's historians debated her words for generations. But deep in the resonance hall, archivists began noticing anomalies again. Patterns forming in the very stone of the chamber. Microscopic vibrations aligning to distant frequencies. The hall itself had begun to hum. And one evening, as dusk fell over the ocean, someone standing at the balcony swore they saw it far to the east, rising through the haze like a dawn that wasn't dawn, a faint streak of light, sunward, trailing no dust, no gas, only intention. The watchers who knew whispered one name: Atlas.